Hey Pre-Calc, this is Mr. Rashid here, and now we're going to go from graphs to functions for both sine and cosine. Now what's interesting about this is the very same graph, you could actually write 4 different types of functions from it. So if you remember, the parent function for sine goes something like this. It starts at 0, and then it goes up to its peak, comes back down, goes to its valley, and then returns back. So that's my original sine. Now I could reflect that sine and get something like this, which is in green. Or I could be dealing with a cosine. So the cosine starts at a peak and then goes down to a valley and then comes back to its peak. So that's the cosine. And then I could reflect the cosine, and so I start at a valley, go up to a peak, and then come down to a valley. All right, so there's 4 possibilities in any kind of graph, and you can pick and choose which one you want, and whichever one is the most convenient is the one you'll pick. And in this case here, for example, let's say I wanted to go for a sine type of thing. That's the blue one there. So then I could go, okay, I'm going to start here and go down here, and then I'm back to my starting position. So that's if I wanted to map a sine to this, that's probably what I would use. Now, if I wanted to do a negative sine, then perhaps I would start over here and go and cycle up, and then, well, now this graph is just cut off, so probably I would not use a negative sign in this case. I can't even read that value, but you can see if the graph goes long enough, you could have used a negative sign and use that function for this. Now, let's look at the cosine. So for cosine, I want to start at a peak and then come down to a valley and then go up to a peak. So those are my positions that I would use if I wanted to map a cosine to this. Now, if I wanted to map a negative cosine, then I would have to start at a valley and then go up to a peak and then come down to a valley. And once again, in this problem, most likely I'm not going to want to use a negative cosine. There's just not enough graph for me to work with. Even if I go down here, there's also not enough graph for me to work with. So the only real possibilities here are I would use a positive sine or a positive cosine with this problem. So let's write the sine and the cosine for this. So I'm going to erase all of this here. Okay, and since we're writing the sine, let's use the blue for that. So the general order I recommend that you do this is you start with the vertical parameters. So the first parameter I recommend you start with is your d value. And your d value is basically your vertical shift, and that is going to be your maximum value on your graph plus your minimum value divided by 2. So it's going to be the average of the maximum and the minimum values that you see on your graph. In our case here, so our minimum is -3 and our maximum looks like it's 5. So we have 5 plus -3 divided by 2. And so that is 2 divided by 2, which is 1. Now, what I do in this case now is when I get my d value, I would just sort of create my center line. So my d value is 1. My center line is roughly over here. Now, with the center line drawn, you can now see exactly what your amplitude is. So I'm going from 1 to 5, so that looks like 4 to me, and 1 to -3, again, that's their amplitude is 4. But let's say you didn't want to do it visually, and you want to use some kind of formula. So for amplitude, I'm going to put the absolute value of the amplitude is equal to max minus your minimum value and divided by 2. So your maximum here was 5, your minus your minimum, which is -3, and divided by 2. And so that's 5 plus 3, which is 8, divided by 2 is equal to 4. So your amplitude is maximum minus your minimum divided by 2. Now the amplitude, like I showed you before, it's going to depend on whether you want to do a negative reflection type of graph or a positive one that matches more like your parent function. Okay, so let's finish off writing the sine function for this. Now, one important thing here is that we drew the center line. So the center line here starts at this value of 1 here. So if we're going to use the sine function, we got to assume, just like our parent, it starts at this point here and then goes all the way across, goes up to its peak, comes down to its valley, and then comes back to its center line. So that is the sine function. So we have already that our center line here is at 1, and then we are going up, our amplitude is 4. Now it seems like, okay, we are starting at 0 here, so this has not shifted at all in terms of the C value. So our C value is going to be 0. So there is no shift. And then we found the D value is equal to 1. So that's our vertical shift, and that's where our center line is. Our amplitude is 4. And then the last thing we have to find is our period, or our B value. So the B value is going to be 2 pi, we're dealing with pi's here, divided by, it looks like we start at 0 and go all the way to 4 pi. So 2 pi over 4 pi, and this looks like a half. So now we have our A, B, C, and D, so we can write our sine function here. This is equal to 4 sine, our B value is a half, C is 0, so this is just sine of half x, and the D value is 1. So this is the final function in terms of sine. Okay, so let's do a couple more. So this time, now you can see in this kind of case here, my hands are tied. I'm pretty much looking at a cosine because it's going from a positive cosine. I'm going from peak to peak here. And notice also that the value for the x-axis is in degrees here, these numbers. So like I said, I start with my D value. So my D value is going to be max plus min divided by 2. So my maximum is 4. Oh, this one's easy. The center line is just 0 in this case. So meaning it hasn't vertically shifted at all from the parent. Then my amplitude looks like 4 in this case. It's going up, and you can use the formula for amplitude. So that is max minus min divided by 2. In this case, it's 4 minus -4 divided by 2, which is 8 divided by 2, which is 4. We got that visually from the graph as well. Okay, so now let's do our B value, and that is going to be not 2 pi, but 360 degrees. So 360 divided by our period. And in this case, we have, so we'll just go from our peak to figure out the period, and that is 180. So if I come back to this here, we have 360 divided by the period, 180, which gives me 2 as our B value. Okay, so the last thing I have to work out is my C value. And here my C value is just 0 because my phase shift, it's not shifted here from my parent function. It's starting at 0. So my C value is just 0 because if I had, let's say I had my peak to peak kind of going like this here, now I have a phase shift that I'm dealing with. But in this problem, I don't have any kind of phase shift, right? That would be a phase shift. So its C is just 0. So let me erase that. And let's tie it all together. So I have y is equal to, amplitude was 4, and then I have cosine, because I'm going from peak to peak, and it's positive cosine. Then my B value was 2, and there is no phase shift. And I can use X here, right? I'm not given any, okay? Sometimes the X-axis is labeled, and you might have something different, but let's just use X. Then I have no phase shift, so I just write y equals cosine 2x plus my D value, and D value is 0, so there's nothing to write there either. So this is my final form here. Okay, so now let's do another one. And once again, we're kind of restricted by the amount of data that we're given on this graph here. So remember, sine goes kind of like this. It starts at 0, goes up to a peak, and comes down to a valley. We're just not given enough information for sine here or sine negative. So let's look at cosine. So for cosine, we start at a peak, and then we come down to a valley, and then we come back to a peak. But this doesn't look like that either. What we've got here is a negative cosine, where we start at a valley here, and then go up to a peak in the middle, and then come down to a valley. So we're going to be dealing with negative cosine. Okay, now once again, the game plan is just to go through and deal with the vertical shifts kind of first. So I start usually with D here, and D is going to be the maximum plus the minimum divided by 2. And that's going to give me my center line. So in this case, these numbers are a little bit difficult to read. That could be 0.5 or 0.75. Let's go with something easier. So let's just say that is 0.5. And then my maximum here is at 7. All right, so 7 plus 0.5 divided by 2. So that is just 7.5 divided by 2. And this then is 3.75. Okay, so that's my, remember your D kind of gives you your center line. And so up here, so that is my center line. And then from my center line, I can kind of visually do my amplitude. So kind of go up and down from that. Or you can use your the formula. So let's do that. So the amplitude is going to be the max minus the min divided by 2. And the maximum in this case is 7, and the minimum is 0.5. Let's divide by 2. So this is 6.5 divided by 2. And so this is 3.25 for the amplitude. So now we've got amplitude, we've got D. So let's keep going. We can do C now. So C is, now in this kind of problem, it's up to us whether we choose degrees or radians. It's really our decision because we're given everything in days of the year here. So I'm going to go with 2 pi. So 2 pi divided by the period. And now let's figure out what the period is. So the period is just when do you go from one point on the graph to a point that repeats. So I'm going to go valley to valley. We don't have much of a choice. That's the only data we have. And it looks like, oh, that looks like 360. And it may even just be 360 days. So I'll go back on this. Instead of using 2 pi, let's go with 300 and let's just do the things in degrees here. So let's go with 360 divided by 360 days. And this is just 1 here. Okay, so now we've got a C value of 1. So what's left? We've got to, oh, I'm sorry, that's not the C value. This is a B value. Okay, so we got a B value of 1. And now we're left with, we have to figure out our C value. And we're actually good in terms of our C value because our valley starts right at the beginning here. So it's just a reflection of the original parent down, and there's no shift at all. So our C value is equal to 0 again, so that's good. So let's write the function. So we've got y equals, and my a value, so first of all, this is a negative cosine. My a value is negative 3.25, and I've got cosine, right? So this is a reflection. Remember, we're going from valley to valley here instead of peak to peak. So negative 3.25, my b value is just 1, and then my phase shift is 0. So it's cosine x, and then plus d, so my d value is 3.75. Okay, so plus 3.75. And that's it. And that is the final function for this. And that's the final example. In the next video, we're going to look at then word problems and situations and how to write functions from those. I'll see you there.